Hello everybody. Welcome back to the Learn Software Development video course. Today we're jumping into the 13th video, and in this one I'm gonna show how for loops work and talk about loops in general while showing that. No theory part today, as I typically try to first show things and then give some theory if needed. Probably this one won't need any slideshow presentation or stuff like that because it comes pretty clear, in my opinion, when I go through the loop and how it works in the debugger. So let's jump right into it, shall we? So I have here already opened my checkers project. So you guys probably already now know how to open it by opening Godot and from the project menu selecting the checkers project, the game, and yeah, then you should open here. And I've already opened the board script here. I've selected script board.gd, and this is the script that we've attached to the board instantiated scene in the main scene. So this is the main scene because it is opened. See these change here based on the tab, but the script depends on what you choose here. And here we can also hover over here and see the tooltip of board.gd being there. So what we're going to do today is we're going to make things dry, so don't repeat yourself. So we're going to remove these lines of code that seem to be doing the same exact thing. Now, I haven't planned ahead how exactly this is going to go, and I don't exactly remember the syntax for loops perfectly on how they go in Godot. I think it's very close to Python, so most likely I'll be fine with that, but let's have a look at documentation first. So that's also if you don't know how to do something, then read the documentation, and Godot does provide some nice documentation, so let's jump into that. So I want to go through loops. Now I can search from here for loops, but I think, let's see, from manual, here is scripting, and then here we've got programming languages and GDScript, and let's see what it tells us here. GDScript reference. Let's see if this is of any help to us. So here we have these four. Okay, here it's showing there's a for loop and there's a while loop. That's loops, and those will become clearer soon. All right, here we have links to for loops and while loops. So documentation is here to help us. So let's click on that one. So for. And it's here in the GDScript basics. So what it says here is that to iterate through a range, such as an array or table, a for loop is used. When iterating over an array, the current array element is stored in the loop variable. When iterating over a dictionary, the key is stored in the loop variable. Okay, what does it mean, loop variable? Well, this is the loop variable. So the for loops statement goes like for x in, and this is the array, or there's a dictionary, so then I, well, here it shows when it prints dict I, it prints the contents of those, but I is actually, if they did print I, it would print A, B, C. And these are these different examples. You could also get a print every character from a string, like this. For I and 3 is a shorthand of saying range 3, and this is also for this, so a few shortcuts. But yeah, I think the for loop is what we're going to use. There's also a while loop, which is while this expression is true, execute this. It's kind of much more simpler than a for loop, but it's not necessarily what we're looking for here in this thing, because we have a certain range of function calls we want to do. But all right, for loop. Loop means we go over and over until a condition to break out is met. And, well, the backbone of the game engine actually has a forever loop, so which is while true, and you probably just write while and then the true, which means it's always on, it never exits the loop, all the time inside that loop. That'll become clearer when we use the debugger, so don't worry yet. So let's have a look at how to do this. What I want here is to remove these many copy-pasted pieces of code, like add piece is a function. It certainly is less code to repeat than repeating all of this every time. But there's still some things to be done. For example, here in the first row, we have Z, which is the position. If we go here to the 3D view, and if we selected this, so Z is this blue line, this axis, and X is here, this red one, and Y is, well, this one up, down. So X and Z. And this is like negative Z. Here's the origin, positive X, negative X. And Y, the same thing, positive Y, negative Y. So we're setting here in the script that Z, for example, let's go back to the dark pieces. The first row is at 0, the second row at 1, and then the third row is at 2. And then we have 7, 6, and 5 for the white pieces. So if I went back here, I click this Y here to get a top-down view. Then this position here for the board, when we select board, shows that we're actually starting from this position, not from the center. This is the kind of, I think it's because of this transform that we've done, or let's see, it's in somewhere here. Let's see, position scale, it's in the anchoring. It's probably here in board. We probably defined it here. So for this row, yeah, here we can see that we're starting the counting from here instead of from the middle, because of how we've built the board rows. They kind of start from here. Tile 1, for example, this one, and this is tile 2 is that one, and this is tile 1. So with tile 1, if we go to its position, it's 0, 0, 0. Go to tile 2, it's 1 on the x-axis. So here red is x, to always check these colors, what they mean. And then here we've got, that's in 2, and so on. But because we started from here and we're instantiating it, it's, we don't want to save this. It's kind of propagating that forward. So it's starting from here, and then here it's got the origin also, like here 0, 0, 1, 1, 2, 3, 4. You get the idea. So here's 0, and here's large Z goes higher here, and X goes 0. But because we start from here as 0, 0, so X0, Z0, we don't have to use like negative numbers to find our place in the board. We just go up higher, which is nice. And here we see the same thing. It starts from there with this board. It would probably, well, no, because we're doing it inside the board. We're putting it here in the script. That's why it actually follows the placement that we have here instead of what it looks like here. So this is in the middle of this world, this instance of board. But here in board, and because the script is attached to this object, not the main world, but it's attached to board, it's these settings of here. So when you put 0, 0, it kind of takes the world coordinates of the scene board, which is the one we've instantiated here. So that's why like 0, 0 works and it goes here, because it's so here. And it's nice that Godot kind of shows where the origin of this thing here is in the kind of scene itself. So we can see exactly from here that this is the origin of this instantiated scene. Now we can double check it here that, okay, here we don't have anything extra, and exactly we can see that the origin is there. So that's why in the script, like, we put the dark piece, or we decided that it's at 0 and 1. So, well, yeah, it's 1 because we only place things into the black tiles, so nothing in 0, 0, so it's 0, 1. And X was, and I think is, now I'm talking, well, 1, 0, X is 1, and Z is 0, so then it would go to X is 1, so it goes 1 right, so there, and Z is 0, so it stays here on Z, the blue one. All right. You can go through that a bit more in detail if you want to try it around, but we know that this works. A few videos back we got it correctly, and there I kind of showed how the piece is moved. And trying out and looking at it, yeah, you'll be able to figure it out. But here, for example, we're repeating things. For all of these, we have true in the first parameter or argument of the function. And here the first one is dark. It's a Boolean, so it's here to tell, like, do we want to set the piece to be dark or not? And if it's true, then we set the color of the material to be dark. So the piece, the game piece, the cylindrical game piece. And if it's false, then it doesn't get changed, and it'll be white by default. So yeah, we're having like add piece repeated many times, true repeated the exact amount of times, and then these are a bit fewer times. So let's break this down like piece by piece. So I'm going to do like the first row first as a for loop, and here we've got like let's see, we've got 4 different values here which change, and everything else is the same. So let's do this simply like this. So let's put for X position. I'm going to call the variable that is the one that we use inside the loop X position, because I'm going to put in in an array that has these X positions. So X here is the second argument. So I'm going to put 1, 3, 5, 7. And then now here I'll write add piece true, and then instead of putting 1, 3, 5, 7, I'm going to put X position and 0. And I'm going to highlight these, and then you can use your mouse or shift and arrow keys, and then I think it was Control K here in Linux that it makes, yeah, puts comments to those. So nice way of commenting out code. And I think I've explained it earlier, but just a reminder, anything starting with a hashtag here in the scripting side is a comment. A comment is something that's only for humans, so it is not interpreted as code for the machine, for the computer. It'll just be ignored. It's just for us humans. So it's a good way of hiding away temporarily functional code, or non-functional, but code anyways you don't want executed, like here when we're trying out this for loop. But let's save this. And the last time I executed this, so I pressed play, it initialized all of the pieces. So now the first row of dark pieces should get initialized correctly. And we can try that out by pressing play. And here they are. And let's just see that I'm not doing anything by chance. So I'll comment out this for loop. Now I save and now I play. Now we won't have the first row of dark pieces. They're missing. All right, so the for loop actually does what it's supposed to. And then if you highlight these lines and press Ctrl K again, you can take the comments away. Really nice handy feature. So with this for loop, we changed 4 lines of code into 2 lines of code. So that's already less repetition. But how does this actually work? So let's put a breakpoint here. So here on the left side of these numbers, you get this little red dot, like a kind of recording dot, much like I have here for this screen recorder. So it's a breakpoint here in Godot and in debuggers in general, very broadly used concept. And let's pause here and look at the value of X position here. So as I said, it'll go through 1, 3, 5, 7, and then X position will hold these values. It'll go in the order as they're put in here. So if I put 7 first, it'll then go through that first. But we can check it in the debugger. So now I'm going to press play again, and this play runs the project. And because we're in the editor, we haven't built the application. So we're inside the game engine editor, the engine itself. So we're always running in debug mode when we press play from here. And okay, now I paused here. Now there's a yellow arrow here, or triangle, showing that we've paused the execution of the software, of the application, into this line. And here on the bottom, it already opened the debugger out, so it's not output, now it's debugger. It used to show this, but we wanted a debugger because it's telling here in this stack trace that there's a breakpoint. And here we can see these locals, so things that are local to this scope of what we're in. We're inside the for loop, so the things local to this is the X position. So here X position is 1. And now if we go, let's not go step into, let's go step over. If we go step into, let's go through it once. So I'll go step into, we go into the add piece function. And now here, X position was put to X, so X is 1, Z is 0. And let's step over, get out of this, and now we got out. And now we're stuck on this line again, because we're still inside the for loop. Now X position is 3. And if I go inside the add piece function, so now we're here, we went inside it, and it took us to the line. Now X is 3 as well. So we're passing the value that's in X position to X of this function, and now we can see it here. It's in the local of this function, the function scope. And now if we come out of here, next X position is 5. And the next one is going to be 7 here. Now it's 7, we're still here. But now that we've reached the end of the array, so X position is now 7, and we know, because we did this ourselves, that there is not going to be a new value from here. So the next thing it'll go to when I go step over is it's going to get out of this for loop and go to this row here, 19, or this line. So let's get out, and there. Now we're here in 19. And now if we actually go to the see here, we've got Godot checkers. Oh yeah, it's not showing anything because it's still initializing, but no, let's turn it off there. But yeah, you kind of got the point. We were stuck here in this loop until we went through the range of things we iterate through, we go through. And this is a range, an array. Depicts a range, and it goes through every member of the array in the order in which they've been put there. Alright, so this works. So we can simplify things. Let's do the second and third row as well. So now I can actually take these away safely because I know it works. So I'll take this breakpoint away and press play. and I know it works. It gets that correctly. So let's apply the same logic to the second row. So exposition in, and let's build an array. An array is like a list. You can think of it as a list. In Python, they talk about lists, which is a more kind of layman's term, a common term for it. But an array, a list of items. So let's put here the same expositions, which are here in the middle. So this time it's 0, 2, 4, 6. And you put a colon, so for exposition, so exposition gets the values of these. First it starts from here, goes on until there's nothing and exits. Now we put here add piece, true, exposition, and 1 for Z. And now again, Control K to comment those out. Press play, and we get the second row. And just for kind of driving in the concept, I'll comment those out, press play. We're missing the second row. So the for loop works correctly. And now let's put it back there. Good. Okay, so that worked, and we can take this away. So what we used to have here was 12 lines of code. Now we have 2, 4, and 6. So we've halved the amount of code we have. Let's not do that. Let's not go again. And then here we have 1, 3, 5, and 7. And again, we'll do add piece. And then here, when it gives you these suggestions based on what you're typing, compress the tab key on your keyboard to autofill. And here as well, exposition. It notices exposition because we're in the for loop. If we go out of the for loop, it wouldn't even suggest that. And this is now 2. Like if I go here and I go XP, it doesn't see exposition because exposition exists only inside the for loop. That's its scope. And the scope of anything is in the area in which it was defined. So exposition is defined only for the for loop, so it's not seen. But if we created a variable called exposition outside of one of these for loops, like in the top, then all of these for loops would be manipulating that one, and you'd still get the value out. There are practical tricks when you might want to do that, but save those for later. All right, and now we have them all there, all the dark pieces. So we have much less lines of code now here. Like we have 12 here and we have 6 here. But there's still quite a bit of repetition if you actually look at it closely. We have the same named exposition. We can of course put these like X, Y, Z if we want to, although it makes no sense to have it other than X because we're putting it to a argument called X. But we're also doing the exact same thing. We only change the exposition, and that is dependent upon what row we are in. So what's the kind of Z position? So on even numbered Z values, or values we put to the Z argument of add piece, we have this set, and on odd ones we have this set of X values. So there is a way in which we can do this also with one for loop. Now that's going to get a bit more trickier, and here's a good moment to pause and write this down and go through what I've just shown here. And if this is the depth you want to take it into today, that's fine. Just stop the video here, pause it here, and if you want to take it to the next level, then just continue from this same video from here where you paused it. Because I'm going to take it to the next level because this is not yet as dry as I want it to be, so don't repeat yourself. I'm still repeating myself more than I would prefer, so I'm going to show you how to do this in a more dry manner. Alright, but there is a pattern already. We can actually here utilize a dictionary to do this configuration. So let's go here and create a variable by declaring var keyword, and let's put a variable called let's say well, let's just call it configuration for now. And this is going to be a dictionary, and I like to type these very statically, so that's why I'm using this notation. So I'm saying variable configuration is of type dictionary, and then I give it the value. A dictionary is defined using opening and closing braces. So some call them curly brackets, but braces is the more accurate term for it. And a dictionary is a collection of key value pairs. And you can have dictionaries within dictionaries as well, but we're not going to go that deep now. But a key is something with which you find the value. So let's say, well, in a dictionary, the keys, like a real world dictionary, the keys are the words you're searching the descriptions or definitions for. So for example, the word car is something that can appear in the definitions, but if you search for the dictionary for the word car in a dictionary, then the word car is the key. And then after that, once you find car from the dictionary, you see its definition and description and examples. All of that content describing what a car is in the dictionary is the value. And to pair, you have a single key, and then you have a value associated to it. So the term dictionary just kind of makes sense if you think of it that way. But let's actually start putting here. So I'm going to use the Z position as the key for the dictionary. So first row would be 0. And then I'm going to copy and paste this array as the value. And this is how you define it. So in a dictionary, you have key followed by a colon, and then after that a value, and then it ends with a comma. And the comma, after the comma, you can then put another key value pair. All right, so then let's take this one. And for the purposes of demonstration and learning, I'm going to put 2 spaces, a comment after this. Again, the comment is omitted. Let's put here first row. All right, just so that we remember if it's not clear to all. And actually, it's probably a good idea anyways, because it's not immediately self-evident. Even, if I came back to this code like a month from here and I haven't had a reason to look at this. So the comments do actually help. All right, so now we've here used a dictionary where we have the first row. This is for the Z, and this is for the X's. All right, so how do we utilize this to have a single for loop? Well, now we put for, let's put Z position in configuration. And let's actually just put here print Z, just for showing, oh, not Z, Z position. That's the name of the variable. All right. So put the debugger and I'll show you what happens here. These ones will still execute as well because I haven't commented out any of these, and here it's just printing stuff to the output. So turn the debugger on and see what happens here. The for loop goes through the configuration, and Z position gets, like it mentioned in the documentation of the for loop, it gets the key. So it goes through the keys in order how they're defined here. So 0 is the first one, and here Z position is 0. If I went ahead forward, now it's 1. And now it's 2. And here this counter position is the counter of the for loop. that it has by its own. Let's actually stop the debugger and put it back on. So here, container position showing it's a dictionary of size 3, so 3 keys, 3 items in the key value pairs in the dictionary. All right, that's what it does. Okay, so with that knowledge, and actually if we check the output, let's actually let it play through. Let's take that away and then press this button here to continue. Now in the output we have printed 0, 1, 2, so the keys here. And you can try that out, just like make a dictionary and put a for loop and put like strings, like so. I can put here LOL, for example, and now it will print LOL 1, 2 here to the output. Just doing this for demonstration's sake. There, LOL 1, 2. So it goes through the keys, and the keys can be of many different types. So a dictionary is really handy, especially for configurations, which is why I'm using it here as the kind of next step of abstracting the logic. All right, but now we've proved to everyone watching this video that we're looping through, so going through the keys one by one in this for loop by writing it out like this. And now we'll take this print away because we actually want to use the Z position. Then we need to find the X position. So now we need to use var to create a new variable and make it X position. And this I know is going to be an array. It'll be an array, and this is going to be configuration Z position. All right, and now let's actually put here print Z, and then let's print this, and then let's not that Z position, X position. So now I'm going to run this. We're still not doing much with it, but I want to show what happens here. So Z position we know is going to be this key here, and there's a value, and we access the values of a dictionary by using the dictionary first and then using brackets. Some call them square brackets, but brackets are just these brackets. We use brackets to say that we're going to access the value of this key that we put inside the brackets of this dictionary. So like we want to get the values 1, 3, 5, 7, which is attached to this key, so then we put the value 0 here inside the brackets after the name of the dictionary, the variable which holds it, and then we get the value here. And this print is here to just kind of show it and prove it. So I'll just run this now. And here it printed the contents of our dictionary, 0, and then I have a colon here, and then the X position. So good, we've proved to ourselves that it works as expected. So where does this take us? Well, here we can actually now do the add piece, true, and now we still use the X position, and then we actually use the Z position as well. So now we get, what am I doing wrong? Oh, nope. We need another for loop. Positions, let's call this X positions. All right, and now it's like for X position and X positions. Like this. Then we can actually comment all of these out. Control K to do that real quick. I don't like that one. Let's here. Now they're all uniform. So, oh, and these become actually doc strings. Huh, interesting. Or some sort of special comments. I have to check what that was. Could have been doc string. Anyways, leave that for later. So what's happening here? We have a for loop inside a for loop. Can you do that? Is that safe? Well, you can do that, and it is safe when you know what you're doing. So when we read this code, we go through each key, and then we grab and grab the x positions, and there's multiple x positions inside this array, so that's why I call this x positions. And then we go through, because we know this is an array, x positions holds this array, and we printed them out down here. So now we're actually doing the same thing we did here, but now instead of having these like in the for loop definition, this whole array defined here as it is, we actually have it here inside this dictionary, and we're accessing the exact same stuff, but it's only stored in this variable. And then we go through that, and then we add piece. Now when I run this, we're not printing anything to the output anymore, but we should get the dark pieces initialized to the board just as we got them earlier. And they're here. And if I take a debugger here and walk through what happens inside the loop. So here we have Z position is 0. Let's go forward. Now we have the X positions, and it shows it's an array. And if we actually click on that, we'll see all of its elements. So this is its position, its index. So at array positions, or the indices of where items are in the arrays, the counting starts from 0. So this is index 0, 1, 2, 3. Instead of 1, 2, 3, 4, it's 0, 1, 2, 3, starts from 0. So we can see here, like index 0 has the value 1. Index 1 has the value 3, 5, and then 7 on the third index. Well, fourth index, but index 3. All right, so now when we go, I think we can close it from there, but we don't yet have any x position variable. That's because we're on this line. We haven't executed this. So when we go to the next line, now we get here x position. Let's go here. Now it's 1, and z is 0. Let's actually add a breakpoint here, and then press this continue so we go through all of this quickly. Oh, press continue soon. Let's go ahead. Now it's added the piece. Now Z position is 0, so that stayed the same. But X positions, it's still the same stuff. But now actually X position singular is now 3. So it's in this one, it's going to be 5 and 7. So let's go forward. 0, 5, 0, 7. So following this logic, next time, now that we've gone to the last X position value available here, we should get out of this loop, but because we're inside of this loop and we haven't exhausted all of the values available here, we're going to be inside this outer loop, but we're going to exit this one. So let's go here, come out from here, and there, we got out from adding a piece, and now we're back here. Cool. And now Z position is actually 1. And now that we grab whatever array is behind this key, because we're using that here, this one should now contain this array. Let's check that out. Let's go to the next line. X positions, it's now 0, 2, 4, 6. All right, so our logic holds true. If I continue like this or like this, see now Z position 1, Z position 2, it's gotten there, and we've added them all. And now that next we initialize white pieces, and now execution resumed. So now here at the bottom, checkers, we've initialized it. But that's what happened under the hood in this for loop. So instead of copy pasting and repeating the same stuff, we define our initialization logic for dark pieces now only once. Control S to save. So we have the configuration, we've defined it once, and then we've defined the logic on how to read this configuration and do the correct thing into life using this logic. So we get this configuration implemented using this for loop. And then we can do the same thing for the white pieces. And I'm going to go ahead and do that. So I'm not going to be talking so much now when I do it here. So just follow along. And then we'll probably take it one more step further, but let's see. I can use configuration here and here. They're not going to be overlapping because this variable exists only when we're inside this function. We've indented it, and the indentation here in GDScript is for noting the scope of things. So this is on the same level as this function, so this is not a part of this function, and that's why this variable does not overlap with that. But for those of you who are paying close attention, you will notice that there is some level of copy pasting or duplication, not copy pasting really, but duplication of logic still going on here. So I'm going to do the same stuff here. So the Z position, X position here, 6, 5. Okay, so 6, and this is going to be 1, 3, 5, 7. Second row, and this was 5, and it is in 0, 2, 4, 6. Okay. And then I can comment those out, Control K. And now I'm actually going to select these, Control C to copy, Control V to paste. And now the white pieces should work as well. Now they're all dark. Why did that happen? That's because I copy pasted. That's dangerous to copy paste. What I also copy pasted here is the true for add piece, so it made them dark. So here in white, this one actually needs to be false, as we can see here in the earlier code. There. Now we did it. But you actually now see the power of the loops and the configurations. With one change of a value, I change the color of all of these pieces to be the same. Like all of them turned dark and all of them turned white with just one change in one line of code, instead of going through here and putting false, 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 or true to all of these 12 times. So we're already getting the benefits of making less repetition. But as I mentioned, for those who have been paying close attention, you actually see that this loop structure here is now identical in both of these things. So what we actually can do here is kind of play around with the functions. Let's see if you guys can keep up with it. So now we have two different functions for initializing dark pieces and initializing white pieces. What if we did it like this? Let's take this configuration, select that, and Control C to copy. I'm going to select these, Control K to comment them out, and let's put this configuration here. Let's actually put here, this is the dark configuration, and let's take the white pieces, and let's put here white configuration. All right. So we have them there. And now we're going to take this and create a new function. So I copied that for loop. I'm going to create a function called initialize pieces. But I don't say what pieces, because as we've done this in here, we can give arguments, so parameters, things that change and are the values of which are referred to, forward to, or copied to the function. Over here, so let's define here dark, because that's actually the argument name here, and we're going to be calling add piece. So dark is a boolean, and this doesn't return anything, so it returns void, so nothing. Now I still have this loop copied in the clipboard, so I'll do Control V and put it here. Now it's going to give me an error because it doesn't know what configuration is, so we actually need something else. We need to give in the configuration because it doesn't see it. It doesn't exist in here. It was here, sure, when I copied it from here, but it's not within this function. It's these ones. So the way to do that here is actually, I want to put these in alphabetical order if possible. So let's do that. So I'm going to put here an argument called configuration, and this is going to be a dictionary. And now with this, problem solved for the scope of the function. So now it's not giving me any red lines here of errors that it doesn't know what configuration is. Now it knows. But now when we actually press play, nothing's going to happen. We're not going to get any pieces because we commented these out. We're creating configurations, but we're not actually using this function. We're not calling it. We've only defined it, but we're not making a call to it. We're not asking it to do anything. So it's empty. All right. And these things, they exist in code, but they're never called. They're not being used anywhere. It's commented out. And these are completely useless as well. They've been defined, but nothing's using them. So what we're going to do now is we're going to go and initialize the pieces using this function. So let's go initialize pieces, and then here we're going to pass in first dark configuration, and then dark is going to be true, and then we're going to, well, let's just leave it there. So now with this, we're giving this configuration here, this configuration, this one, this configuration is assigned here. We're passing in this configuration here, which is mapped to this position here, goes to configuration, and it goes here, and now we should get the dark pieces, like so. Nice. So now let's do the same thing for white pieces. And then here we need to put false. Oh, but that doesn't work. Why is that? Well, that's because we're actually defining them with the same configuration, and it's wrong. We should put here white configuration. There. Interesting. Oh, again, the dangers of copy pasting. Add piece is true. So actually, if I had this as dark configuration, but we're not using dark anywhere. If I highlight configuration, you get this small little dimmer highlight around configuration elsewhere. But when I double click dark, there's nothing. So here we actually need to put dark so that the value from here gets passed into here. And now we'll probably have white pieces at the dark configuration spot. So if I commented that out, we get dark pieces here, but now we're going to put this to the same spots, but dark is false, so we'll get white positions in the same spots. That's what I guess is going to happen. I've never tried this. No, they're probably overshadowed by the dark ones already there. All right, but let's actually not just do this correctly. So let's put here white configuration and play. And now we have the board all set. All right, cool. So what we've been able to do is we've actually been able to get rid of these two functions that used to have the first, second, third rows all in their own lines. And now we have this add piece, most handy function to add a piece based on the position and if it's dark or not. And we've here created a function that goes through a configuration and calls add piece. Nice. And we've got configurations here. And now we actually can and should take away these things. And we've defined our configurations and we're passing them in and all good. Nice. But there's still some repetition here. So let's see if I can take this deeper in a sensible way. do have the option of having dictionaries within dictionaries as well. So what we can do is, now this may or may not be good, or it's kind of borderline, is it any more readable or maintainable than something else? But I'll just show it here for demonstration's sake. So let's do here, for example, a new variable. So we have these still here. We want the white and dark configuration. Now let's do here piece configurations. And this is also a dictionary. And then here, we're going to put dark pieces, like first. So here we're going to put true as the key. And then here we're going to pass in the dark configuration as the value. So now we have the key true, and it's dark. And then if we put false, and we put white configuration. All right. So now what we have is a dictionary within a dictionary. Let's actually put the debugger on break here and see if we can have a look at this in the debugger. Let's see, piece configuration, dictionary of size 2, and here it shows there's a key true and false, and it has a dictionary of size 3. And here it has 0, 1, 2, and it's got an array here. And this is actually the same 0, 1, 2. Dictionary, and white configure is 765. And if I went here to false, we have the 765. So it's a dictionary. See, piece configuration dictionary. And then we have 2 more dictionaries here. So we have nested dictionaries. So that works. All right, so what's the benefit of this then? Well, we can now then go and use a for loop to go through the piece configurations. So for dark piece, so let's call dark. We've used dark all the time, so let's for dark, because we're going through the key. So this is dark configuration, dark true, dark false. This is not the most verbose code, so I'll probably take this a step further in the next video to kind of show how I'd really want to do this, but we're still learning here. So let's be forgiving to ourselves and forgiving of not having the best code yet. But anyways, what I want to show here is I'm going to here create a loop that goes through the configurations here and calls this initialize pieces based on this configuration. So we can go for dark in piece configurations, and then here we can go initialize pieces, and we'll go piece configurations dark, dark. All right, that looks funky. All right, now what is going on here? Well, let's first try it out. Press play. Everything works as it should. All the pieces in the correct place. So why? Why does it work so nicely? Well, again, this is a dictionary. This is the key. When we're looping through the keys of the dictionary, dark gets the value true, and then it gets the value false, and then we run out of keys and we get out of the for loop. And then here we call initialize pieces, and the first thing we need to give here is the configuration. So the configuration here is the value behind the key. So then we call the dictionary and access the value behind the key by using the brackets and putting the key's value into it. So then here, this is just a kind of, instead of having here var configuration dictionary is piece configurations dark, and then here we've got, we can go configuration, for example. This will work just as well. So I can kind of shorten the amount of lines I have in my code by not creating a separate variable, which I immediately use here. I can just put whatever comes out of it directly here. So that's what it means here. And now we don't have these two separate initialize pieces calls, but they're actually in a for loop. And this is the power of for loops and loops in general, but especially for loops is you have, like it's in the documentation, you have a range of things you want to go through. And when you know that range and you want certain things to be always done in certain conditions within that range of processable items, then for loop is something that removes the amount of code you need to repeat. You let the computer do the repetition for you, but that of course means you need to program the stuff in such a way for it to work. So now we have to come up with the concept of using dictionaries as configurations, all of these, and then looping through those dictionaries and then making this function that has two loops, loops and a loop within a loop, and here we actually call the add piece. What we're essentially doing is we're going through this dictionary, passing the dictionaries within this dictionary into this one, and here we're going through the dictionary that's here, and then going through the values in the arrays and passing these specific Z and X values here to add piece, and that's how we get things out there. Like if I, for example, put here 1, here in the first row of the whites we'll actually have 1 piece now misplaced. It's here instead of here, just to kind of prove my point that the configuration actually works. And now it's here. So yeah, this is what the code looks like. So I suggest you pause the video, copy this stuff now as it is, and then once you've copied that, unpause, and then go and copy this initialize pieces if you haven't done that yet. And then add pieces has not changed at all. That should be as it has always been. But now we're actually getting a bit deeper into the programming part when we're starting to use loops. And we've created a function that has loops, and a loop here inside this ready function, which is a Godot Engine, a node classes kind of essential function which is executed whenever something is about to come to the scene tree. So you can think of it as something is about to enter the application's view, if that helps you understand it a bit better. So when something's about to be shown, it does this before they are shown. And then after all that is configured, then it displays things. But yeah, copy those pieces of code, and there are still things here that could be simplified. There are some patterns I'm already picking up here. And we can actually next time work on abstracting this even further using maths. For example, here we notice that we have this array is 1, 2, 3 times, and this same array is actually another 3 times here. And this array is always associated with Z positions, so keys in the dictionary, which are even, and the contents of them are always odd. And then this array, which is also repeated 3 times, is associated with Z positions which are odd in each case. So if I highlight this, 1 is odd, 7 is odd, 5 is odd. So we have a certain mathematical pattern here, and we can actually define this initialization of pieces using maths instead of dictionaries as well. So maybe we'll give that a shot as well, or then we can use some other kind of structure. But there really is no one single way of doing this correctly. You can do this in so many different ways, and that's also the fun thing about programming and software development. If as long as you follow the rules of the environment, like the Godot engine in our case here, and GDScript rules, then doesn't really matter that much how you do it, in the kind of sense of getting something simple like this done. But then, of course, certain ways of programming something do affect the speed of execution, and that's where like certain structures of data processing are not as sensible as others, because some things take a longer time to load in the computer than others. But those are the kind of optimization things that we'll get to later. And I always say this to developers who are starting out, and not just developers, but also in like larger software systems. When we're designing things, is first we get something working and then we optimize. So already earlier we got something working with the initialize dark and initialize white pieces, and now we optimized it further. Not necessarily optimization in the sense of it being faster for the computer to execute, but more in like optimizing the maintainability of the code, so that we have like a central place, a single source of truth for defining the configurations, and then they're executed all in the same way, so we don't need to remember to write or call the execution logic separately after we've done it once, because it reads the configurations each time. So that's the kind of optimization we did this time around. But also knowing and utilizing nice tricks you can do with numbers is something that is very powerful in software development, because they are very fast for the computer to execute. Instead of doing lookups to dictionaries or lookups and going through like lists or arrays, and then in the case of Godot here, if you can do just a simple mathematical operation, it'll probably be much faster. So we're going to have a look at this thing of odd and even numbers and see if we can come up with a function to initialize the pieces where we don't use these configurations, and not necessarily a for loop, but we might use a while loop. We might have a like single configuration, let's see, but a simpler structure in terms of not having dictionaries within dictionaries and arrays in dictionaries. I think we could simplify this. At least in my opinion, it's simpler than this current structure, the way I imagine it now. So, but yeah, let's see where we get to next time. But this was this video's lesson, which was for loops. And let's see if we ever get to while loops. You can go through documentation. Maybe I'll just show it for comparison's sake next, like how to do that. Probably in the next way in which we load the pieces to the board. It's easier to demonstrate the differences between for and while loops, because the structure of how the determination of the piece's position is done is going to be in such a structure where it should be fairly simple to also be done in while loops. So maybe I'll do it for the sake of showing not just the power of maths, but also the gives me the chance to show how a while loop works and how that compares to a for loop at the same time. But yeah, that's all, folks. Thank you for watching, as always, and hope you learned something from it. If something was confusing, then try going through the video again. I hope I was explaining clearly enough. If I didn't explain something clearly enough, then you can of course Google this stuff as well, like or Bing it or whatever, Yahoo it. I don't really care what search engine is used. DuckDuckGo it, but browse the internet, search it, like search while loops, for loops. Many programming languages have these concepts. That pretty much every programming language I've used has had those both structures for loops. They're done in different ways in different languages, but Python, for example, has lots of tutorials on how to do for loops, and they're pretty much the same, very close between GDScript and Python. So if there's some video that helps you better understand and it better shows what happens, and like some animated video inside a loop, then those are worth checking out. But yeah, leave a comment if you need help with something or have some ideas that you want me to follow, or if you need some links to some videos that might explain some things in a slightly different way than how I explained it here, I'd be happy to help and point you to such tutorials written for more video form. Yeah, see you guys next time. Thank you for watching. That's scene, save, X, and there. That's all, folks. Goodbye.